Question 8. A circle C has centre M 6, 4 and radius 3. Write down the equation of the circle in the form x minus a squared plus y minus b squared equals r squared. Well, this is the formula for a circle centre AB and radius r. So if we want the centre to be 6, 4 and the radius 3, the equation will become x minus 6 squared plus y minus 4 squared equals 3 squared. Part B. Show that the angle TMQ is 1.0766 radians to 4 decimal places. Well, what we need to realise here is this is a right angled triangle, and the reason it's a right angled triangle is that is a radius of the circle and that is a tangent, and the angle between a tangent and a radius is 90 degrees. So if I knew the length of PM, because I know TM, then I could use simple trigonometry to find that angle. So let's find the length PM. PM, using Pythagoras, will be the square root of the difference in the x coordinates squared plus the difference in the y coordinates squared. So it's 12 minus 6 squared plus 6 minus 4 squared. So the length PM is equal to the square root of 12 minus 6 is 6, square root is 36. 6 minus 4 is 2, square root is 4, so that's 36 plus 4, which is root 40. So if I call this angle alpha that I'm trying to find, that's the adjacent side, the 3, and PM is the hypotenuse, so we can simply say that cos alpha is adjacent divided by hypotenuse, 3 over root 40. So this angle alpha is cos the minus 1, 3 over root 40. Let's use a calculator. First of all, change it from degree mode into radian mode because we're working in radians. And then I want 3 divided by root 40. 3 divided by, and on this silly calculator, you put the root sign in after the number, and that comes to 0.474. And then I want cos the minus 1 of that. Cos the minus 1, and we've got 1.0766 radians as required. To 4 decimal places, 1.0766. So alpha is equal to 1.0766 radians. And the final part of this question, the shaded region TPQ is bounded by the straight lines TP, QP and the arc TQ, as shown in figure 3. Find the area of the shaded region TPQ. Give your answer to 3 decimal places. Well, what we need to realise here is the area of the shaded region is just the area of this triangle, TPM, minus the area of this sector, TQM. So let me write down shaded area is equal to area of triangle minus the area of the sector. Right, first we'll find the area of the triangle. You might initially think we could use a half base times height, but we don't know TP. We could find it using Pythagoras because we now know that that's root 40, but it's easier to use the alternative formula for the area of a triangle, which is a half AB sine C. So area of triangle is a half AB sine c. And all that means is a half one side times another side times the sine of the angle in between them. So in this case, that's going to be a half multiplied by 3 multiplied by root 40, which we found in the last part of the question, multiplied by the sine of 1.0766 radians. So that's what we want to do on the calculator. Let's make sure we're in radian mode, and it's 0.5 multiplied by 3 multiplied by root 40 multiplied by the sine of 1.0766, sine of that equals 8.3517. 8.3517. Now the area of the sector. And the formula for that is a half r squared theta, where r is the radius and theta is the angle in radians. So in this case, it's a half multiplied by 3 squared multiplied by 1.0766. So we want 0.5 multiplied by 3 squared is 9 multiplied by 1.0766. And that comes to 4.8447. And so the shaded area is equal to 8.3517 minus 4.8447. And when we do the subtraction, that comes to 3.507 units squared, whatever the units happen to be. And that concludes question 8.